Good morning, everybody, and welcome to INE's webinar on CCIE Data Center version 3 ACI object workflows. My name is Brian McGahan. I am a CCIE and Data Center, as well as routing and switching security service provider and a CCDE in design. Any questions that you guys have about this session, you can feel free to send me an email. My email address is bmcgahan@ine.com. You can follow me on Twitter at Brian McGahan or on linkedin.com/in/bmcgahan. Now, in this section, we're mainly going to be focusing on two main topics. How do the objects work in the Application Centric Infrastructure, or the ACI system for Cisco systems? And then we're going to look at configuring basic connectivity through the ACI and talk about how the objects fit together, and then talk about their workflow of the objects. So there's basically only going to be one slide for today, which is going to be what are the different objects and then how they fit together. But it is definitely not self-explanatory how the system works in terms of how we just get basic connectivity, even in terms of just trying to ping through the system from one port, excuse me, from one port to another. There's a lot of different objects that are going to come into play that we need to configure and bind together in order to get just basic connectivity through the system. Okay, so let's go ahead and log into the system, into the ACI. And in this case, we're running ACI version 3.2. So I'm going to log in as my user admin. Okay, and we're brought to the main screen for ACI, which shows the system health. Okay, from here you can see the overall status of the system. It says nodes with health less than or equal to 99, or tenants with health of less than or equal to 99. So right now it means that everything is at 100%. So nothing is configured in this system yet. But as we start to go through our configurations, if we run into any problems, these health indicators would tell us some information about configuration problems, or maybe some physical problems in the system. If there was like a cable down or something like that, it would show here with either the node health, talking about the fabric nodes like the switches, or the tenant health, which is going to be our configuration. Okay, so where we're going to start our configuration is under the Fabric tab. Under the Fabric tab, we have Fabric Inventory, Fabric Policies, and Fabric Access Policies. Fabric Inventory is going to show us the physical switches that we have configured in the system. So if we go down to pod 1, this is going to show us what we have for the topology of the system. So right now we have the APIC controller that's physically connected to the two leaf switches. We have leaf 101 and 102, and then we have spine 201 that is physically connected to the leaf switches. Okay, if we look at our topology diagram, down from the leaf switches, we have connectivity to our Nexus 7Ks. So we're going to be using the 7Ks as if they're end hosts in this particular example. And specifically, we're going to be focusing on 7K1 and 7K2. These are going to be our end hosts that we're using to send traffic into the system. So let's go ahead and configure these 7Ks. We're just going to configure basic IP addresses on them, and then we're going to try to ping through the system in order to get connectivity to these two devices. Okay, so from 7K1, if we look at the show LLDP neighbors, okay, actually the feature LLDP is off, so let's go to global config and turn the feature LLDP on. Okay, same on 7K2, let's go to global config and type feature LLDP. And then let's look at the show LLDP neighbors. Okay, we'll see one kind of minor important point about the ACI system is that LLDP is enabled by default, but CDP is off. So we're going to be using CDP as part of our interface policy in order to check connectivity to the end system of the ACI. So if we look at the show interface status, we have all the interfaces disabled right now on the 7K. So I'm going to go to interface E17. And they'll shut this port, which is connected to leaf 101. Okay, same case on 7K2. If we look at the show interface status, All the ports are disabled, so we're going to go to interface E17 and no shut. And then we're going to show LLDP neighbors. And we see we have connectivity to leaf 101 on port 1/1 of the leaf, which is local port 1/7 on 7K1. Okay, so on interface 7K1 or interface E17 on 7K1, we're going to say no switch port. And we're going to put an IP address of 10.0.0.71/24. And 7K2, we're going to do the same thing. We're going to say no switch port. We're going to put an IP address 10.0.0.72/22 or /24 and no shut. And then our ultimate goal here is just to get a basic ping going between 7K1 and 7K2. We're trying to ping over to 10.0.0.71 from 7K2. Okay, so we can see up to this point, we do not have connectivity between the 7Ks. This is because the ACI system is considered to be a zero trust system, which means that we're not going to be able to forward any traffic through until we configure the system for connectivity. So it's unlike a catalyst switch where you're just able to plug the ports in and then start forwarding traffic. So we're going to have to configure the different objects in the ACI before we're able to ping through the system. Okay, these objects are going to be configured under fabric access policies. So the fabric policies, this is going to be talking about the connectivity between the leafs and the spines themselves. And the fabric access policies are going to be talking about from the leaf switches down to the access layer. Okay, from fabric access policies, we're going to start with the quick start wizard. We're going to configure an interface, port channel, and virtual port channel. So let's go ahead and open up the wizard. And the first thing that we need to do is to configure a switch profile. So if we go back here to our view of the objects, we're in the right-hand portion of the screen here where we're configuring a switch profile. The switch profile is going to select what particular leaf switch that we're talking about, which is called the switch selector. The switch selector is then going to have a switch policy group, and the switch policy group is going to be made up of a number of different policies that talk about the behavior of the switch. Okay, once we configure the switch profile, we're then going to configure what interface we're talking about on the switch. So in this case, it's going to be interfaces E11 to E12 on leaf 101. And under that, we have a policy group that's going to be made up of different policies, like is CDP running, is LLDP running, is LACP running. So anything that you would normally do on an interface level of a regular Nexus switch or a Catalyst switch, this is going to be configured with the interface policies and then grouped together with the interface policy group and then called under the interface selector of the interface profile. Okay, we're going to see that the wizard is going to take care of a lot of this for us, but once we configure the wizard, we're going to go back and verify the different objects that we have configured. So we'll see how the different objects fit together. Okay, so the first thing that we need to do is configure the switch interfaces. We're going to add a switch profile. Okay, so we're going to select the leaf switch. In this case, it's leaf 101. And the switch profile name by default, it's called switch 101_profile. Okay, so let's go ahead and save our work. We now have switch 101 under the switches on the left-hand portion of the screen. Excuse me, and then we're going to configure plus under the switch profile to configure the switch interfaces. Okay, so we have the option of the interface type. Is this an individual interface? Is this a port channel? Is it a virtual port channel? Or is this a fiber channel interface? In this case, we're configuring just individual interfaces from leaf 101 down to 7K1 and 7K2. So our interfaces are going to be 1/1 to 2. Okay, we then have our interface selector name, which is going to be the interface profile name, which is switch 101_1-ports 1-2. So it's going to be configuring both ports 1 and 2 at the same time. And then we have our interface policy group. It says we're going to create a new interface policy group. And it's asking us what are the different attributes that we want to configure on this particular interface. Okay, so we have the link level policy. We're going to create a link level policy. This is going to choose what is the speed of the interface. So we're going to say that this is a 10 gig interface. We're going to explicitly name these policies so that we know what the configuration is. So we're going to say that this is 10 gig. Okay, we have the MCP policy, which is the miscabling policy or the miscabling protocol, which is going to be the replacement for spanning tree on the access layer for the ACI leaf switches. So it doesn't run spanning tree down to the access layer. Instead, it runs this miscabling protocol. So we're going to say MCP on. Okay, we have the spanning tree interface policy. If we create a spanning tree interface policy, this would be if we wanted to configure BPDU filter or BPDU guard. So even though we're not running spanning tree actively, we're still listening for spanning tree packets, and we're doing spanning tree snooping down to the access layer so we can participate in the spanning tree domain. Okay, in this case, we don't need to configure a BPDU filter or a BPDU guard, so we're going to cancel this one out. Okay, we then have storm control policy. So if we wanted to filter based on broadcast, unicast, or multicast packets, we could either do this as a percentage of the interface, or we could do it in packets per second. Okay, in this case, we don't need to do storm control, so we're going to go ahead and cancel out of this one. Okay, we then have the Ingress data plane policing policy. Would be if we wanted to limit the amount of traffic that's coming in the interface. So this is essentially like a QoS policer. So what happens when we get to the conform value? We would be transmitting the traffic. Once we go above the dedicated value, we would drop the traffic. Okay, in this case, we're not going to do any policing. Okay, we then have priority flow control policy and the slow drain policy. These are going to be for storage connectivity as well as the fiber channel interface policy. Okay, in the upper right, we have the CDP policy. So as I mentioned previously, CDP is disabled by default on the ACI. So if we look at the show LLDP neighbors from the Nexus 7K, we see connectivity to Leaf 101. But if we look at the show CDP neighbors, we don't see any information about the Leaf. So in our particular case, we're going to enable CDP, which is going to make sure, as just another sanity check, that we have our interface policy group properly applied to the interface level. So once we apply this to the interface and we look at the show CDP neighbors from the Nexus 7Ks, we should see connectivity to Leaf 101. Okay, so under CDP policy, we're going to create a CDP interface policy. We're going to say that this is CDP _ on. Okay, with CDP enabled. We have our LLDP policy. So we're going to have LLDP _ on. Okay, we have a monitoring policy that we could use for monitoring the link. Okay, in this case, we're not going to do any monitoring. We have a layer 2 interface policy. This is going to be if we're doing Q and Q tunneling. Okay, also this chooses the VLAN scope, whether the VLAN numbers are globally significant or they're locally significant to the port. This allows you to reuse the same VLAN number between 2 different customers or between 2 different tenants. By default, the VLAN numbers are like on a regular Catalyst switch or on a regular Nexus switch, or you can only use them once, that they're going to be globally significant to the individual switch. Okay, we have the egress data plane policing policy. So same as the ingress data plane policing policy, but in the opposite direction. So that's going to be outbound on the port. We have IPv4 net flow. We have IPv6 net flow. And then we have our layer 2 switch policy that we can configure. But the important one really about this is just that we're turning CDP on. so that when we go to our Nexus 7 case and we look at the show CDP neighbors, we're going to see that we have connectivity down to the leaf switches. Okay, next we have our attached device type, which is considered to be the domain. So this is asking us, what are we plugging into the port? Okay, in general, what this really means here is, does the APIC have a plugin that's going to be used to talk to the device on the other end of the link? So the default option here is ESX hosts, which is going to be talking to the VMware distributed vSwitch on vCenter. But in our particular case, we don't have vCenter. We're not connecting down to hypervisors. We're connecting down just to other switches that we're using as end hosts. So we're going to consider this to be a bare metal domain. Okay, it doesn't necessarily mean that these are bare metal servers that we're connecting to. It just means that the APIC doesn't have a plugin for any type of operation that we're talking to the remote device. Okay, we also have the application virtual switch and the application virtual edge. This is going to be the ACI plugin that's running inside of Hyper-V or inside of Microsoft SCVMM, which is going to be similar to the VMware distributed vSwitch, except it's going to be the specific plugin for ACI. Okay, we have external bridge devices, which is going to be if we're connecting to another switch, which is also called a layer 2 out or an L2 out. We then have external routed devices if we're connecting to a layer 3 device, which is also called an L3 out. Okay, we then have Microsoft Hyper-V, or if we're running storage, it could be a fiber channel port. But like I mentioned, in our case, we don't have a plugin to talk to the Nexus 7 case. So we're going to consider this to be a bare metal domain. Okay, we need to give the domain a name. So we're going to call this our bare metal _ domain. And then we need to give it a range of VLANs that we can potentially apply on the ports. So this is not the same as the allowed list that we would have on a Catalyst switch or a Nexus switch. This is just going to be administratively what particular VLAN numbers can we encapsulate on the interface. So in this particular case, I'm going to say just everything 1 through 4094 that we could be using these VLANs on these particular ports. Okay, so we're going to save our configurations, save, and then finally submit. Okay, if we go back to the 7 case and we look at the show CDP neighbors, we now see that we have connectivity to Leaf 101 on port 1/7, which is the local port E1/2 on the Leaf switch. And on 7K1, if we look at the show CDP neighbors, we have connectivity to Leaf 101 on our local port E1/7, which is on the remote port E1/1. Okay, and again, our goal here was that we're just trying to ping through the switch where we're trying to ping to 10.0.0.72. But as of yet, even with the interface policy applied, we're not yet able to send any traffic through to the other end of the link. Okay, so if we go back, if we go back to our objects here, right now what we've configured is everything up to the domain in the middle, including the VLAN pool. The attachable access entity profile was automatically generated by the wizard. We configured the interface policy group, which had the policy CDP on, LLDP on, 10 gig, etc., were the attributes of the interface that we were configuring. Okay, the next thing that we need to do is to configure a tenant and then configure our tenant policies, which are going to control what happens when traffic actually comes in the port, and it's going to be classified by what we call an endpoint group or an EPG, and we need to apply the EPG to the interface in order to actually allow us to send traffic through the system. Okay, so if we go back to the ACI, we're now going to go to tenants. Okay, we're going to add a tenant. Okay, by default, there's 3 tenants in the system. We have tenant common, tenant infrastructure, and tenant management. So tenant common is going to be for any shared resource that we have in the system. Like if we have a DHCP server that we want to service multiple customers through, we could put that in the common tenant. Or if we had like a common link to the WAN that we wanted to share between multiple tenants, we would put this in tenant common. Tenant infrastructure is going to be for the connectivity from the leaf to the spine. So this is where ISIS is running on the back end, automatically routing the traffic between the lease and the spines. And then tenant management is if we want to do in-band management as opposed to out-of-band management, which is what we're currently doing. We're currently doing out-of-band management to the system. Okay, so we're going to add a tenant. Okay, we give it a name. We'll say that this is tenant Brian. Okay, a lot of different options here. So we have the GUID, we have the monitoring policy, the security domain, and the VRF name. We're going to leave all of these as the default. And we're going to leave this checkbox checked that says, take me to the tenant when I click on finish. So we're going to click on submit. And this is now going to go under tenants, and we're now under tenant Brian. Okay, under tenant Brian, we need to configure a routing table. So under VRFs, we're going to right click and we're going to create a VRF. Okay, we'll call this VRF1. Okay, under the VRF, we have policy control enforcement preferences enforce, which means that we are doing filtering between different endpoint groups on this particular routing table. So this is like a deny any at the end of an access list. If we were to check the box that says unenforced, this would be like saying permit IP any on your firewall, and it would not be doing any filtering based on layer 3 or layer 4 information. Okay, normally the policy control enforcement direction is ingress. So as the traffic is coming in, we're checking against our contracts, we're checking against our policies to see whether we want to filter the traffic, either whether it's going to be permitted or denied. Okay, the next option, it says we're going to create a bridge domain. So bridge domain in ACI is what you would kind of think is the equivalent of a VLAN in the other switches. It's going to be our layer 2 forwarding construct, but we don't call it a VLAN because we're going to be using VLANs for the tagging at the individual port levels. Okay, so we're creating a VRF, and we're now going to create a bridge domain. Okay, specify the bridge domain for the VRF, so we're going to call this BD1. Okay, this is a regular bridge domain. It's not going to be used for fiber channel. We have endpoint data plane learning on, which means that we're going to learn the IP address of the endpoints when the traffic is coming inbound. So once we are done with our policy, we're going to look at the show endpoint from either the CLI or look under the bridge domain under the GUI, and then we're going to see the 10.0071 and the 10.0072 as the different endpoints that are forwarding traffic through this particular bridge domain. Okay, limit IP learning to subnet. It says limits IP address learning to the bridge domain subnets only. Okay, so we're going to configure a default gateway on the ACI, and it's going to be limiting traffic to that particular subnet that we configure by default. Okay, also configure the bridge domain MAC address, and we have a standard MAC address that's listed here. This is going to be used if we're doing like vMotion for different virtual machines, that when they move between the port numbers, the default gateway layer 2 address is going to stay the same, as opposed to having a new different layer 2 address on a different port. So in our case, we're not doing vMotion, but we're going to leave this as the default for configuring the bridge domain MAC address. So this is just like in Catalyst switch or Nexus switch. If we were to manually go to the interface and manually configure the MAC address on the SVI, but in our particular case, this is going to be on the bridge domain interface, which is going to be the equivalent of a VLAN interface in like a Catalyst or a Nexus switch. Okay, we also have IGMP snooping. So if we're running multicast, we can create the IGMP snooping policy. We have the neighbor discovery policy. If we're running IPv6, we can configure the neighbor snooping policy. and we have ARP flooding off by default. Okay, so let's go ahead and click finish. And this is going to have created two different objects here. We have our bridge domain and we have our VRF. Okay, under the bridge domain, under subnets, this is where we would configure the default gateway for the end hosts that are contained in this particular bridge domain. So we're going to create a subnet. And we're going to say the gateway IP address is 10.0.254/24. Okay, it says the default is that this is private to the VRF. So if we have any type of layer 3 routing, it means that we're not advertising this to our routing protocols. If we were running like OSPF or BGP and we wanted to do an advertisement to that particular protocol, we would say that this is advertised externally. Okay, if we wanted to leak this to another VRF, we can say it's shared between different VRFs. Okay, in our case, we're going to leave this just as the default, which is private to the VRF. Okay, our next step is we're going to configure our application profile. So we're going to create an application profile. The application profile is basically just a container for the endpoint group. So there's nothing that we need to do here other than just give it a name. So we'll say app profile number 1. Okay, and submit. Under the application profile, we're going to configure an application endpoint group. Okay, the endpoint group is the classifier for the traffic as it enters the system. We're going to be learning the endpoints on the particular ports, and then we're going to be applying filters between endpoint groups using contracts which are similar to access lists. Okay, so we're going to create an application endpoint group. We'll say this is EPG1. Okay, a number of different options here that we have. So we have intra-EPG isolation is unenforced, which means that it's basically acting like a regular VLAN. It's not acting like a private VLAN. So intra-EPG is filtering within the endpoint group. Okay, preferred group member exclude, which is going to be like a default permit. So different endpoint groups that are in the preferred group are going to be able to talk to each other by default. Okay, the default option here is we're going to exclude. Okay, we then need to choose our bridge domain. So what particular layer 2 forwarding construct is this endpoint group in? So we're going to put this in bridge domain 1. Okay, and then we're going to finish. Okay, if we go back to the Nexus 7 case, we still don't have connectivity because we're missing the last step, which is going to be to apply the endpoint group to the interface. Okay, so a lot of steps just to get basic connectivity through the system, because like I mentioned, it's considered to be a zero trust system, or it's going to be denying all traffic by default. Okay, so under endpoint group 1, we need to associate the domain. So if we go back to our object workflow, the endpoint group is going to call the domain. Domain is calling the attachable access entity profile, which is then calling the policy group. Policy group is called from the interface selector. Interface selector is called from the switch selector. And this is how we bind the endpoint group physically to the interface. Okay, so if we don't configure the domain, then the objects are not going to bind together. So we're going to add a physical domain association. Okay, we have our bare metal domain that we had previously created. So go ahead and submit. And then our very last step, we're going to have static ports that are assigned to the endpoint group. Okay, so we're going to deploy the static EPG on a port channel, virtual port channel, or interface. So we select the node. So the node being the switch, we have leaf 101. Okay, select the port. We have Ethernet 1/1 is going down to 7K1. And then we specify what is the VLAN encapsulation that we're going to be using as the traffic comes inbound. So the ACI leaf is expecting the traffic to be .1Q encapsulated by default. So we have to give it a value here, let's say VLAN 100, but we're not using VLAN encapsulation on the other end. So we're going to say that the mode is access untagged. Okay, it says warning, assigning a static path with an untagged encapsulation to the EPG may cause traffic on this interface to be disrupted due to untagged configuration. Okay, so it's just warning us here that if we're not using the VLAN encapsulation, that there might be a mismatch in the VLAN number and we wouldn't be able to accept the traffic yet. Okay, so let's go ahead and submit. And then we're going to apply it to deploy the static EPG on the port channel, virtual port channel, or interface. So we have leaf 101, port 1/2 is using VLAN 100. And then the mode is access untagged. Okay, so we have 2 ports that are now applied to our endpoint group. Okay, so this should be enough now to get connectivity between the 2 different endpoints. Okay, which we do have connectivity between 7K1 and 7K2. Okay, if we go back to the GUI, we can verify the different endpoints if we go under the bridge domain. So under the bridge domain, we're going to go to, I want to say that this is under operational. Unless this is under the endpoint group. Let me go back to the endpoint group. Oh, it's under endpoint group and then operational. Okay, so we have client endpoints. We learned 10.0.0.72 and 10.0.0.71, which are on these particular interfaces. Interface E1.2 of node 101 and interface E1/1 of node 101. Okay, so let's look at how the objects are tying together here in order to actually allow the connectivity through the system. So we're going to go to endpoint group 1 and under let's see, what I'm looking for is an object that says show usage that shows how the objects are tied together. So this might be under the bridge domain. There we go. So under bridge domain, under policy, it says show usage. Okay, it says that the bridge domain is being called from application profile 1. From endpoint group 1, and this is being called from the node 101, leaf 101, and then it says the resources, click to show the details. Okay, so this is where we can follow through the object browser in order to figure out, are the objects properly connected together. Okay, so it says this is under Ethernet 1/1 layer 1 physical interface configuration and Ethernet 1/2 layer 1 physical interface configuration. Okay, so it tells us what particular ports have this bridge domain applied onto it and the endpoint group applied onto it. Okay, if we go under the application profile, under the policy, under general, under show usage, okay, it says this table shows the nodes where the policy is being used and other policies that use this policy. If you modify or delete this policy, it will affect the nodes and policies shown in the table. Okay, so from the endpoint group, it doesn't show that it's being called from the bridge domain. But from the bridge domain, it does show that we're calling the application EPG. Okay, so let's look at the same thing under the VRF, under policy, and then under show usage. Okay, it says the VRF is being called from bridge domain 1. Okay, so we can follow this through to bridge domain 1. And then under bridge domain 1, we could show usage again. And it shows the application profile. So the point being is that the objects are properly connected together. That if it was to show something blank here under policies using this policy, it means that that object would basically be orphaned, that nothing is calling the policy's usage. Okay, the other place that we would want to check this is under the domain. So under the endpoint group, under the domain, we have the bare metal domain. And then this is going to be calling the domain is going to be calling the attachable access entity profile, which is going to be calling the physical interfaces of the actual switches. Okay, so if we go under fabric, we're going to go under fabric inventory, fabric membership. Actually, no, under pod 1. Under Leaf 101, we're going to go down to our interfaces. We're going to go to our physical interfaces and physical interface Ethernet 1/1. So we can see that these two interfaces are green, meaning that they're configured. The rest of the interfaces are red because they're disabled by default. Okay, it says Ethernet 1/1 has the usage of an endpoint group. So we're going to scroll down, and what we should see here somewhere is what we call the attachable access entity profile. Okay, the attached entity profile is bare metal domain at entity P. It says the identifier for a group of external entities with similar infrastructure policy requirements that are connected to this interface. Okay, so if we go down to show usage, we should see that we have the endpoint group applied to the interface. And then we see the different policies using this policy. So this is going to be the CDP policy we defined, the LLDP policy we defined. These are all going to be called under that particular port. Okay, if we go under fabric access policies, this is where the objects actually exist. So if we go under physical and external domains, and under physical domains, we have the bare metal domain. Okay, from here it says we have the attached entity, associated attachable entity profile called bare metal domain at entity P. So this object was auto-created by the wizard, but this is kind of the glue that ties the system together in the middle, where the attached entity profile is what's being called from the domain and then being referenced from the interface policy group. Okay, so without the attachable access entity profile, we're not going to be able to forward any traffic through the system because it's not going to be associating the tenant policies, which is the logical configuration on the left, to the physical interface configuration on the right. Okay, but luckily the wizard did this for us. It created the objects and it attached them together automatically in the system. Okay, we also have a VLAN pool that was created. So VLANs 1 through 4094, this was the range that I gave it under the wizard. But this is calling, the VLAN pool is calling the VLAN numbers, and then it's calling the bare metal domain. So if we look at show usage, it tells us that the policies using this policy are the bare metal domain, and that this is applied to Leaf 101. So if we go to Leaf 101 show details, we see that ports 1/1 and 1/2 have these objects bound to it. Okay, so they're part of that bare metal domain effectively. Okay, under the physical domain, if we show usage, it says we have the attachable access entity profile, bare metal underscore domain underscore at NDP. So policies using this policy, if we go ahead and click on the attachable access entity profile, and then we scroll down to show usage. Okay, this is where we now have our interface policy group. So we have switch 101 underscore 1 dash ports 1 to 2 policy group. If we go ahead and open this up, this is going to be where we had created under the wizard those different options that we wanted to apply onto the interface. So CDP is on, the miscabling protocol is on, LLDP is on, and the rest of the values have default values. Okay, we then have the attached entity profile. So the bare metal domain at NDP. Okay, we continue to scroll down and click on show usage. It says we have an access port selector. So switch 101 underscore 1 dash ports dash 1 dash 2 type range. Okay, so if we click on this policy, this is calling the policy group, switch 101 underscore 1 dash ports dash 1 policy group. And it's calling the access port selector, which is 1/1 to 2. Okay, notice that it doesn't show us what particular switch that we're talking about here, though. It's just telling us that it's running on ports 1 to 2. We would have to show usage again. And then it says nodes using this policy is leaf 101. Okay, so leaf 101 is calling, or the switch profile of leaf 101 is calling this access port selector, which is calling ports 1.1 to 1.2, and then we're applying the interface policy group to those particular interfaces. Okay, so under the objects here, this would be the interface selector that we're looking at here, but it's not yet called from the switch selector under this particular screen. We would have to continue to look at where the objects are bound to in order to see that it's actually being called from leaf 101. Okay, so this was under fabric access policies, under physical and external domains, under physical domain, and then under the bare metal domain. Okay, under pools, this is where we have our VLAN pool. So we have bare metal domain underscore VLANs. So we had the VLAN range 1 through 4094 that we could potentially use on the interface level. And then we were encapsulating VLAN 100 on the interface as access untagged. Okay, if we look under policies, under our interface policy, this is where we have all of those different options. For example, the CDP interface policy, so we have CDP on. Okay, CDP on, if we look at show usage, it says it's being called from switch 101 underscore 1 dash ports 1 to 2 policy group. Okay, so these are the individual policies that we can modify. You can also change the defaults here. So default here, CDP is disabled. We could enable CDP automatically for all ports. Okay, we have the LLDP interface policy. We have LLDP on. And then we had the MCP policy, MCP interface policy. We had MCP on. Okay, so these are all the attributes of the interface that you would normally just go to like interface E1/1 and then say like CDP enable from a regular switch. But in the case of the ACI, these are all individual objects that are going to be called from the interface policy group. Okay, if we look at global policies, this is where we have our attachable access entity profile. So we have the bare metal domain at entity P. It says what domain is associated to this. We have the bare metal domain. So if we show usage here, we can see what policy group this is being referenced from. So switch 101, 1 ports 1 to 2 have that attachable access entity profile assigned to it. And it's being called from the bare metal domain, which is then calling the VLAN pool. So it's taking us both to the left and to the right of these objects. But the point being is that the objects are properly attached together because the wizard is automatically doing this for us. Now we could skip the wizard completely and we could create all of these objects manually. But the potential problem is that you run the risk of forgetting to call one of the objects from another one. And then the end result is that you would not have connectivity through the system overall. Okay, so definitely easier to use the wizard when you're getting started using the system. Even though it is automatically naming these objects, it gives a kind of a strange naming convention. That's the reason why you would want to potentially manually create these objects. If you have a specific naming convention that you want, then the disadvantage of the system is that you cannot rename the objects. You would have to delete them and then recreate them. Okay, under policies, we have the switch policies. So for example, if we were configuring a VPC domain, it gives us the option for some of the timers, control plane policing for the leaf. Okay, we could configure the strict COP policy. For a spanning tree policy, this would be if we're connecting down to multiple spanning tree. And then we would want to match what the instance names and the VLAN mappings are of the multiple spanning tree domain into the ACI leaf. Because if there is a topology change notification generated inside multiple spanning tree, we would want to flush out the MAC address table of the leaf switch. So this is a little bit confusing, the spanning tree policy. It doesn't mean that we're running spanning tree on the ACI leaf. It just means that we're agreeing between the multiple spanning tree instances, the instance numbers, the instance names, and then the encapsulation for the particular VLAN numbers. So we could clear out the CAM table if there's a change in multiple spanning tree southbound of the access layer. Okay, so then we have the interface policies, leaf interface profiles. This is where we have the profile interface selector. This is calling switch 101 underscore 1 ports 1 to 2, blocks 1 to 2 policy group. So if we show usage, we have the switch profile, and then we have the leaf interface profile, which is going to be the access port selector. Okay, so this is where it's binding to the actual leaf. We have the leaf selector, which is saying that this is switch 101, okay, which is leaf 101. And then we have the associated interface selector profiles, which is switch 101 profile interface selector, which if we double click on this, or if we show usage, it should show us that what particular physical interfaces we're actually calling from the interface selector. Okay, so the interface selector is calling ports 1/1 to 2. And it's applying this particular policy group onto it, which is going back to our policy group, which has the individual interface policies. Okay, but again, luckily the wizard is creating these objects for us and it's binding them together. So we don't have to configure the individual leaf interface selector or the switch selector or the interface profile names, it's creating this for us automatically when we create the configuration from the wizard. Okay, if we go under switch policies, under leaf switches, under leaf profiles, we have switch 101 _ profile, okay, which is calling the leaf selector leaf 101. It should also be calling an associated interface selector. Okay, so this is how the switch is binding to the physical interface on that particular leaf, calling switch 101 _ ports 1/1. Okay, we also have the switch policy group itself, which in this case is using the default policy group. But this is where we would have, if we have policies that applied to the switch, we would have the switch the switch policy group that would be calling, for example, like the spanning tree policy that would be talking about multiple spanning tree. Okay, so let's go ahead and look at adding a new interface to the configuration. So let me go ahead and open up 7K3. And let's say that we wanted to add its configuration on here. So let's look at the show interface status. This is going to be port 15. Let's no shut. In global config, we're going to turn feature LLDP on. Show LLDP neighbors. And we should see here shortly that we have connectivity to leaf 101. Show interface status. Okay, so we have leaf 101. The remote port is 1/3. So we want to reapply the interface policy group to interface E1/3. And then we're going to deploy the endpoint group on that particular interface. So now that we have the interface policy group defined, it's going to be a little bit easier for us to go through the config. So we're going to go through the wizard again. We're going to configure an interface, port channel, and virtual port channel. We're going to select the switch. So we have switch 101. We're going to click plus to configure the switch interfaces. We're going to say this is interface 1/3. And then we're going to choose the interface policy group. Okay, so we have switch 101, 1-ports 1 to 2 policy group. Click save, save, and submit. Okay, we're going to go back under tenants, under application profiles, under our application EPG, and we're now going to deploy the static EPG on an interface. Okay, so we're going to select leaf 101, port 13. Okay, we were using VLAN 100 and it's access untagged. Okay, if we go back to 7K3, let's go ahead and configure an IP address on the link. IP address 10.0.0.73/24, no shut. And let's see if we can ping to 10.0.0.71. And we do have connectivity. So it's only the very first run through of creating the object structure that is the most difficult part of creating basically the skeleton workflow of how the objects fit together. And then when we want to configure additional interfaces, it's as simple as just applying the interface policy group to that particular link and then deploying the endpoint group on that particular port. Okay, but definitely is not self-explanatory how these objects fit together. So understanding the ACI system, you do need to understand how this workflow works. And then if there's a disconnect in the objects, when you're troubleshooting connectivity, you need to be able to figure out how the objects should be fitting together in order to properly troubleshoot the system. Okay, so we have an example of the ACI object workflow. So we have the interface policies, CDP on, LLDP on, BPDU guard on. Those would be the individual interface policies. This is then called from the access ports policy, which is going to be called from the leaf selector. So leaf 101 underscore ports is calling the profile leaf 101. It's called from the profile leaf 101, which is selecting the leaf and then the access ports policy. Okay, we have the attachable access entity profile, which is called our access ports, called from the domain, access ports, calling the VLANs access VLANs, and then we're specifying our endpoint group. Okay, under the endpoint group, this is also where we would have our contract. So when we're filtering traffic between different endpoint groups. Now in our example, we only had one EPG, so traffic within the EPG is going to be allowed. Traffic between EPGs is dropped by default unless we have a contract which is permitting the traffic. Okay, so in this example, we would have a filter for port 80 and port 443, port 443 for the web ports, and then those would be applied onto the web server. Okay, we then have the bridge domain, which is calling the subnet. The subnet basically being the default gateway of the end hosts that are part of that endpoint group. Okay, then the bridge domain is being called from the VRF. The VRF is called from the tenant. Tenant is going to be the largest portion of the hierarchy under the logical configuration. And then to the right, we have the physical configuration for the leafs and the interfaces. Okay, so let's go ahead and go to some questions here. There's a question, does the wizard automatically add the extra words to the naming? Yes, it does. So like that add entity P that was added to the attachable access entity profile. So if we go under fabric, access policies, and then under policies for global attachable access entity profile, I had created the domain called bare metal underscore domain. So the letters that are in capitals are what I created. It added the suffix at entity P to the end. Okay, there's a question, is there a recommended naming convention for the objects, meaning the interface policy group? There's not really a recommended naming convention other than you name it something that makes sense when you come back to it afterwards. So for example, if we look under the interface policy group that we had previously created, this interface policy group is called switch 101 underscore 1 ports 1 to 2. It doesn't really make sense now that this is being called from port 3. So this is one of the reasons why you would want to not use the wizard and you would want to manually name these, because unfortunately you cannot rename the objects once they're created. Okay, so notice the interface selector, we have two selectors. One is calling an interface range of ports 1 to 2, and then port number 3 is called from its own interface selector. So it can be kind of confusing. It looks like this is applied just to ports 1 and 2, but technically it's also applied to port 3 as well. Okay, there's a question, this being a zero trust model, is there anywhere I enabled a contract to allow ICMP for the pings to work? In this case, I didn't need to because the three ports, excuse me, are in the same endpoint group. So if we go under tenants, and we go under the endpoint group, and then we go under, I want to say it's under operational. These three IP addresses, 10.0.0, 71, 72, and 73, they inherently have connectivity to each other because they're all part of the same endpoint group. So if I was to put it in another EPG, then I would need to configure a contract in order to explicitly allow the ICMP packets through. But since they're all part of the same EPG, traffic is going to be permitted automatically. Okay, there's a question, can I create a different AAEP with overlapping VLAN ranges, or do they have to be different? Yes, you can overlap the VLANs under the VLAN pools. The difference is that when you go to actually do the assignment, the default value is that the VLANs are globally significant. So you would have to use unique VLANs when you're applying them to the different customers. Okay, but there is an option under the interface policy to create the VLANs as locally significant, but the default value is that the VLANs are globally significant when you actually apply them to the interface. Okay, there's a question, are there any specific considerations if you were connecting ESXi with the VDS without VMM integration, or can it be traded as bare metal? Okay, so the key here is that when you go to the Quick Start Wizard, okay, so let's go like we're configuring an interface, and then it says attach device type. This is talking about, does the APIC have a plugin that is going to be interacting with the device on the other end of the switch? So ESX host, you would only choose this if you were using VMM integration, which basically means the APIC is going to log into vCenter, and then it's going to be communicating the VLAN numbers automatically back and forth between the vCenter and the APIC. But if you were using ESXi and you were not using VMM integration, you would just choose bare metal. Okay, so bare metal, again, it doesn't necessarily mean that it's a bare metal server. It just means that it's something that you're not using the plugin from the APIC in order to talk to. Okay, there's a question, is there an advantage of MCP over spanning tree? It's just a simplification of the system, that the miscabling protocol is going to be running to make sure that you don't accidentally wire two ports together. But spanning tree is not going to be running from the access layer southbound. So it needs still some way to prevent loops at the access layer, which is going to be the MCP protocol as opposed to spanning tree. Okay, there's a question. Every environment I've seen seems to use the network-centric deployment of ACI. Why is application-centric seemingly so rare? What differs so much between the two, and what makes it so difficult to deploy and support? So basically, the difference between network-centric and application-centric is that application-centric assumes you know the traffic patterns of all of the end hosts that are sending the traffic through the switch. And the potential problem is that if you're filtering more than you need to, which I mentioned, it's a zero trust model by default, you're dropping all traffic, then it's going to break your applications. So a lot of people just skip over the application-centric deployment and just go with network-centric, which means you're matching your subnets to your bridge domains on a one-to-one basis. And it's more similar to kind of like a classic Catalyst or Nexus deployment. And then you're grouping the applications based on the subnet as opposed to based on their functionality. Okay, we have time for maybe 2 more questions here. When I configure the EPG, what is the meaning of the VLAN and the access untagged field? It means when you're sending the traffic in to the system, what VLAN number is it expecting to receive. So in our particular case here, we had traffic coming in from 7K1 as untagged, simply because I wasn't using a VLAN number from the 7K. Okay, so if I was using a trunk port, if this was trunking from the 7Ks up to the ACI, then I would need to match the VLAN number on both sides in order for the encapsulation to match. Okay, so there's a question. I created the VLAN pool for the domain, and under the EPG static assignment, I assigned it a specific VLAN. In a production environment during migration, you would ideally assign the VLAN in the traditional data center to the same VLAN tag in the EPG. Exactly. So if this was connected to a VMware machine, whatever tag number you're using on the VMware port group, that would be the tag number that you would want to assign in the endpoint group under the ACI. Okay, there's a question. So we can enforce isolation even in ports that are in the same EPG? Yes, you can. So the default is that traffic within the EPG is allowed, but technically you can filter within the EPG if you want to. Okay, there's a question. Can a single AEP be used for more than one domain, physical and virtual machine managed? Yes, it can. And the way that you would do this is the wizard won't be able to do that for you, but if you go under the attached access entity profile, so if we go under policies, attachable access entity profiles, you can add the domain. And then this is where you could apply, for example, like a layer 3 out. Okay, or a vCenter domain would be for virtual machine management. There's a question, can you have more than one access port assigned per AAEP? Yes, you can. Okay, so that's going to do it for our presentation for today. I hope you guys enjoyed the brief session here on ACI. There was one last question here. Which courses cover ACI in detail? It's under CCIE Data Center. So under the CCIE Data Center Learning Path, there's a section for ACI in application network-centric mode, and then also in application-centric mode, which talks about the virtual machine management. So let me briefly show this. Under my.ine.com, if we go under Discover, under Learning Paths, then under CCIE Data Center version 3, there's 2 courses here, Application Centric Infrastructure in Network Centric mode, and then Application Centric Infrastructure in Application Centric mode. So these 2 courses cover ACI in much more detail than we were able to just briefly talk about today. So thanks everybody for coming out today. I hope you enjoyed the session, and I hope to see you back here for further webinars in the future with INE.